Hi guys, today in math we're going to be talking about partitioning. So our objective today is partition circles and rectangles into equal parts and describe those parts as halves, thirds, or fourths. Today we're going to focus on halves. Now, if I were going to share this cookie with you, and I told you I was going to give you half of this cookie, is this half? Why not? That's right, because they're not equal parts. If I offered to give you half of my cookie and I gave you this, is this half? No, this part is a lot smaller than this part. But if I offered to share and give you half of my cookie and I separated our cookies like this is half. Okay? Half means equal parts. How many equal parts? 2 equal parts. Halves means 2 equal parts. The parts have to be equal or they're not halves. So let's look at a rectangle. On your screen, you have a rectangle. Well, how can we partition? Partition means separate into parts. How can we partition our rectangle into 2 equal parts? Well, one way, we could cut it down the middle. And if you have a piece of paper at home, you can use a rectangle, cut out a rectangle piece of paper and fold it in half this way and see, are both sides the same size? All right. But is this the only way we could partition this rectangle into halves? No. What if we split it down the middle this way? Is this part the same size as this part? Yes. Is that the only 2 ways that we could partition this rectangle? Think about it. Well, what if we went from corner to corner? Is this part the same size as this part? Yes. So sometimes there's more than one way to partition a shape into equal parts. So let's look. Did I partition this rectangle into halves? Why not? Good job. This side is a lot smaller than this side. If this was a candy bar, I would not want this part. I would want this part. All right? Remember, when we talk about halves, we're talking about 2 equal parts. Let's look at a circle. Do you think that we can partition a circle into halves, which would be 2 equal parts? Let's see. What if we went? It's not working. Let's try again. What if we went from here to here? Well, it's not partitioning the circle vertically and it's not horizontal. It's at an angle. But is this side the same size as this side? Yes. Let me move our shape around a little bit. Let me curve it a little bit and get it straight up and down. All right, that's pretty close to being up and down. Let's see. If we partition it, we can partition it this way. Is this section the same size as this section? Yes. That means we successfully partitioned our circle into halves, 2 equal pieces. Let's try again. Can we partition our circle here and have halves? No. This side is a lot smaller than this part. Remember, when you partition a shape into halves, it is 2 equal parts. Okay? Let's look at some of the work you'll be doing on this today. Now, you're going to be looking at shapes and deciding whether they are partitioned into halves. So let's look. Let me get a pencil. Here we go. When we look at this, is this side the same amount as the shaded side? Yeah. The white side is the same amount as the shaded side. So this would indeed be partitioned into halves. Look at B. You have a shaded part and a non-shaded part. Is the shaded part the same size as the non-shaded part? No. So is the circle on B partitioned into halves? No. These two parts are not equal. Remember, to be halves, it has to be equal parts. Look at C. Is C partitioned into 2 equal parts? Well, let's look. How many parts do we have? 1, 2, 3. Is that 2 equal parts? No, that's 3 parts. So C is not. I'm going to put an X over the ones that are not halves. B was not half. C had 3 parts. Remember, halves are 2 equal parts. Look at D. Here we have a shaded part and a non-shaded part. Are they the same size? Are they equal? Yes, they are. So D is, the rectangle in D is partitioned into halves because the shaded part and the non-shaded part are equal pieces, 2 equal parts. Look at E. We have a shaded part and a non-shaded part. So we have 2 parts. Are they equal? Yes, they are equal in size. So E is partitioned into halves. Look at F. Here we have a circle. Is partitioned into a shaded part and a non-shaded part. So we have 2 parts, but are those parts equal? Because remember, to be halves, it has to be 2 equal parts. Looking at the non-shaded part and the shaded part, yes, those are equal parts. Okay. You're going to have the opportunity with the problem set to circle shapes that have 2 equal shares, one of them shaded, just like the one we were looking at on the previous page. You have shaded and not shaded. And you're looking for 2 equal shares, one shaded. So when you go through the problem set, make sure you're reading those directions carefully and you're looking for 2 equal parts. Now, on one part of your problem set, you get to be the one to partition the shapes. Remember, it has to be 2 equal parts. So be careful when you partition these shapes. You're going to shade half of each. That means you're going to color in one part of each shape after you partition it into equal parts. All right. Good job, guys. See y'all later.